Welcome back to Behavioral Finance and FinTech. I am Andy Kim, your Dr. Finance. Until now, we talked about the evidence for and against efficient market hypothesis. All right? Now, we also learned about why this is such an important issue, EMH. Those are the centerpiece and the building block of almost all neoclassical economics theory, okay, in every aspect. But we see so frequently and systematic way that the market is not efficient, okay? Now, we are going to move on to the individual investors or each investor's decision rules, right? We're going to start with something called expected utility theory. That's going to be our benchmark from the perspective of neoclassical economist, right? And then we'll move down to questioning those assumptions about this functional form and the probabilities and all these kind of things. And finally, we will get down to the concept called prospect theory. And we're going to talk about, on the way, we're going to talk about overconfidence and then disposition effect and this kind of things, right? Loss aversion instead of risk aversion. But as I said before, we have to start with the Economist Benchmark, which is expected utility theory. Okay, fine. Let's see. Which is longer visually, right? What you see on the screen. You know that, these two lines are supposed to be the same length, but your eyes tell us that it's not. Our eyes tells that this one seems longer than that one, okay? Illusion matters. Our brain is circuited differently somehow. And do you think this is a motion picture, like a JPG file, or not a motion picture like MP4 file, or static picture like JPG file? This is clearly a JPG file, static one, but our brain does not tell us that way. It says it's like a flag moving back and forth and like this way, right? And how about this one? Is it JPG file or MP4 file? Clearly this is a JPG file, but our brain tells us that it's circling round and round and round we go, round and round, one round we go. Why is that the case, right? Our brain, it has to do with our evolutionary process. We are all animals. You and me, baby, ain't nothing but mammals. So let's watch this one. Like, turning around. And the thing is, I got to tone myself down over here. Okay, Anyway, so the yellow and purple, it's like a... Why does it seem like it's circling around? Okay? Has to do with our evolutionary process. Our ancestors who were good at this kind of illusioning, right? Perceiving this illusion, had a better chance of survival. Why is that the case? I don't know. Maybe because in the hunting ground, when you go to the hunting ground and then, look for your prey and rabbits somewhere, and then, but all of a sudden you see a stripe of yellow and black. Yellow and black, and then you realize that's a jaguar or like a tiger. What do you have to do? You have to run for your life fast. The faster you recognize those patterns and then just run away, those guys had better chance of survival. Anyway, the guys who were slow in pattern recognition became dead meat. Okay, so even for a static yellow and black stripes going on, you'd better recognize those things as moving, like, ooh, there's tiger, and then just move it, run away. Perhaps it has to do with that kind of, predator avoidance or kind of things, but that's my hypothesis. I may be wrong. Anyway, all that I'm trying to say is that the illusion, our brain tells a different story from what the fact is. Right? The fact is it has to be a static one, but we don't perceive it that way. Well, when it comes to investment or when it comes to competition or martial art or boxing, competitive sports, right? Here's Mike Tyson's famous word. Everyone has a plan until they get punched in their mouth. And then, once you get a punch, you become animals, right? No strategy. Come on, man. It's just, animal spirit. Makes you fight or flight. And before getting into stock investment, we always perceive ourselves as, just like Michael Douglas over here, we are like coolest and then brainiest investors, rational, right? And utility maximizer. I'm going to be razor sharp in decision making. I'm not going to make a stupid mistake like you, and just like that. But the moment you put your own money in it, we all become monkeys, right? We all become monkeys, become stupid. And then we get we get swayed by our psychological biases here and there, okay? That's behavioral finance. And even worse, when you get caught by your spouse and your kids, shame on you. Happens like this, okay? I told you before in the first class, you'd better talk to your spouse before making investment, and then two brains working together would be better than one brain doing something crazy, okay? So that's one point I want to make. And then let's move down to the expected utility theory in that sense, right? Our computer razor sharp model by the Economist called, who is it? Von Neumann Morgenstern, right? Von Neumann, German sounding, yes. It's from Eastern Europe, I think. Hungary or somewhere. And then is a genius scientist. Okay, he was a code breaker during the Second World War. Okay, mathematician, and then you remember the ENIAC, the first computer in 1945 or something, or 40s, right? He was working those machines and then breaking this secret code of German ships and then planes and all these kind of things, right? After the Second World War, right, all these guys got laid off, I guess, right? Got no job. What do? The Wall Street calls you, right? They need some money, the mathematical brain, right? And then those economists are working together with them. So come on. And then, why don't you add value to the economic theory development? And then they did it like this. So what did they develop? What they developed is something called expected utility theory. Expected utility theory. What is that about? This is about utility maximization story when you go to stock market or gambling or any kind of decision making under uncertainty. Okay? The world is not certain. There is a lot of uncertainty involved in your decision making, and whether you go for I don't know, like a stock investment in Samsung Electronics, should I invest that money into Asiana, or should I sell those stocks and then invest in Bitcoin, right? All these kind of risky decisions we have to make, and life choice, right? Do I have to go for Goldman Sachs, or do I have to prepare for CPA exam, or should I go for, apply for law school, all these kind of things. It's risky decision making. Nobody knows what the heck is gonna happen, right? So that is kind of a gambling, right? Life is like box of chocolate. You never know what you're gonna get. That's Forrest Gump words, right? Wordings. Go ahead and watch that movie. That's an interesting one. Anyway, the thing is, when you enter certain gambling, okay, let's say gambling of coin flipping versus gambling of roulette, right? What is the utility that you get? Okay, which gambling would you go? Well, they say any gambling that maximizes your expected utility. Huh? Not the maximizing the whole utility? some definite utility, but expected utility. What the heck is that? They did, let's see, bring those expectation concept, probabilistic expected value concept into the utility theory. Before that, we had marginal utilities and then utility maximizations coming from Austrian school of thoughts, Marshallian, right, kind of economist, right, standard economist way of doing it, maximizing your utility, right, economics 101 or basic economics, right, you remember those concepts, right, maximizing your utility, derivatives, all these kind of things, yes, marginal utility. It matters over here too, but what they introduced is the probabilities associated with it. Okay, and then the things that we're going to consider is the final stage wealth, right? After, let's say, coin flipping, head I win $1 million, tail I get nothing. Okay, half and half chance, right? Well, at the final stage, I will end up with either $1 million or $0, right? And at the end of final stage, right? 1 million versus 0, those are going to be my final stage wealth, right? Of course, initial wealth, I have it. Let's say I start with $1 million, and I will, if I flip a coin and I'm lucky, I will end up with $1 more million. In the end, my final stage wealth will be 1 million plus 1 million. That's $2 million, right? On the other hand, if I get tails, I get nothing, but I still have $1 million in my original vault, right, in my pocket. So I will only have $1 million, right? That's my final stage wealth in tail, right? So what you see on the graph over here on the horizontal axis is my final stage wealth. Even though I said income, it's just wealth after the gambling result. Okay, the gambling in coin flipping will be either of these two. Okay, 대박 or 쪽박, or like a jackpot versus nothing. Okay, empty-handed. And I'm going to have some final stage wealth. Depending on that final stage wealth, I'm going to have experience my utility. Okay, the utility level is shown in the vertical axis, and what you see on the black line, curved line, right? It's concave, it's like concave, right? 오목하게, right? And then what do you see? Well, we see a couple of things over here. The more you get, the happier you are. Of course, right? We are all greedy, right? We want some more. I want it all. I want it all. Yes. And then the interesting thing is, we get happier as we get more, but to a decreasing degree. Decreasing marginal utility, similar, right? So decreasing degree. And not just that, okay? And then here, okay, the expected utility is not really about this, either of these two, K or G dot, but it's about F over here, the red line over here. What the heck is that? Well, expected utility about this coin flipping, right, is like before I join this coin flipping game, 짤짤이, right, in Korean terminology. What is my expected utility by getting into this coin flipping business, right? I have other gambling options. I may go to hot two, or blackjack, or kind of a or slot machine, or any kind of things, right? But why would I go for coin flipping? I will compare those expected utilities of coin flipping and expected utility of casino, not casino, like a slot machine, and then another gambling like roulette and things like that. Which one gives me the best or highest expected utility level? That's the question that these guys are addressing. Okay, now how do we get there? Well, at the final stage, you're going to have either of these two, a utility level like that, but there is a probability associated with each outcome that you get. Okay, each outcome half and half, and then half and half times respective outcomes, right? Respective utility, and UB and UA, right? Probability weighted average of these two, that's our expected utility. This P is a probability of having A, this guy, and 1 minus P is having this guy, okay? So P, 1 minus P times UA and UB respectively, and adding it. That's our expected utility associated with the coin flipping. That's this level, okay? Okay, fine. So whatever expected utility that I can get, I will go for the highest expected utility game, okay? That's my rule of thumb, okay? Now, what else can we learn from this one? Well, there are other possible things we can, interesting features in this utility function, okay, utility function. The thing is, usually people are risk averse, okay? People hate to take risk. So that, let's compare this guy versus that guy, F and I, okay, is that right? Right, F and I. What is this? Well, this is the exact probability weighted average between these A and B, right? If you look at this, right? Probability weighted average, PA times 1 minus P, PA plus 1 minus P times B, right? That's this guy. And if you're going to receive that expected value of the outcomes, like for example, I said $1 million if I get head and $0 if I get tail, right? What's the average of it? $500,000, half and half chance, right? So this point is $500,000, and then I tell us that we would be, or I would be as much as happy, or I would be happy as much as this point over here. Okay, I would be happy as much as this point if I get $500,000 for sure. Okay, again, this point, okay, this point I is my happiness if I get that $500,000 risk-free without taking any risk. Okay, without going for that gambling, I will be happier. And then this one F, right, is I'm less happy, or less happy than this point. Why? Because there is an uncertainty that I may end up with nothing. Okay, and I would not be that much miserable because I also have a probability of ending up with a $1 million over there, right? So weighted average of these two, that's J. Okay, this point IJ. Is it I? Did I say F? No. This is J. Okay, sorry about that. Anyway, so that's that. The degree, right, of risk aversion. Okay, degree of my risk aversion shows up in two ways. One is the difference between. I have to shut my mouth up, but I'm gonna keep on talking, finishing 3 minutes, and then move on to the next video. By the way, IJ, right? My risk aversion shows up in 2 dimensions. One over here, and the other is over there. Okay, and people, the economists, typically talk about this degree of risk aversion in the horizontal way. Okay, what is that? Well, H. What does this H level tell us? Well, this is something called a certainty equivalent. What do you mean? Well, what is the certain cash payment to me? Certain risk-free cash payment to me that will make me as happy as joining that coin flipping of $1 million versus $0. Okay, instead of going into that gambling, I just give me some risk-free payment for me. Okay, and I'll just 먹고 떨어져. It's like I'll just be happy as happy as doing that gambling. That's this point. Okay, H. And then you see the difference between these two, M, right, and this one, the weighted average of A and B. This difference has to do with the difference, blue arrow, it has to do with your degree of risk aversion. Okay, the risk aversion. The more risk averse you are, this will be bigger. you are extremely risk averse, it will be like close to this one, from here to there. If you are less risk averse, it will be like very tiny small. Or even if you are risk neutral, there will be no difference, so that it will be identical over here. So the certainty equivalent will be identical to this J point, okay? And then if you are risk seeking on the other hand, okay, it will be negatively expanding like this direction, okay? So how does that show up in terms of your risk aversion? How does your risk aversion show up in your utility curve over here, the black line, right? The utility curve, the more risk averse you are, the more concave it will be. Okay, the more concave like this. Extreme degree of risk averse guys, it will be like almost perpendicular. Okay, don't give me any risk uncertainty, right? Instead, if you are less risk averse, this concavity will slowly disappear. It will get closer and closer to this straight line. When your utility function is exactly matching, or how do you say, 합동, or identical to this red line, if your utility curve is identical to this red line, it's a straight line, we call that you are risk neutral. Risk neutrality is such an important concept in your derivatives pricing. Remember that. When is that? I mean, that's the situation when you are happy exactly as much as the dollar amount that you get in your gambling. Okay? If I get $1 out of this gambling, I'll be as happy as 1 degree. And if I get $100 out of the gambling, I'll be as happy as 100 times what I used to be happy. Exactly that number. Okay, linear relation, risk neutrality, okay, is there. And if, on the other hand, if your utility curve is convex, 볼록, right, 볼록, to this curve like this, as opposed to this one, concavity and convexity. If your utility curve is like convex like that, that's the situation when you are such a risk lover. You are more like a gambler. Give me more risk. That's that situation. Okay. In that risk-seeking situation, your risk premium will be negative, right? So that's the concept that I want to talk about as expected utility refresher. RP over here, risk premium. But I said this magnitude, right? The difference between your certainty equivalent and expected wealth is related to your risk premium, but this risk premium is not identical to the risk premium that I told you in the capital asset pricing model or the multi-factor model, those risk premium, okay? Those risk premiums are the usual risk premium that we talk about in finance, right? And the risk premium over here is just a translated version of, I'm not going to ask you in your exam, but this is just a dollar translated version of the risk premium of you as an individual investor, okay? As an individual investor in dollar terms, right? Whereas the risk premium that we talked about in CAPM or the quantitative trading, that's the risk premium of the average investors in the market shown up in the expected returns, okay? So that's that. I'm going to talk to you in the next video. So thanks for watching. Bye.